Welcome again to part 2 aspect of the topic Ionic and Chemical Equilibrium. If you check our channel, you will notice that we have posted the part 1 aspect of it where we discuss what happened to weak acids. Yes, we also see formulas we derive concerning it, especially how to calculate pH of a weak acid. Yes, in today's video, we want to discuss weak base. Let's see what happened to weak base. Both place, and place. Don't forget that in the field of production, in the industries, weak acids and weak base, knowledge of it are very important because most production are channeled to be in weakly acidic form or weakly basic form. Why? Recall we said weakly acidic products or weakly basic products have both ionized and unionized parts. Yes, when taken into the body, you will see the unionized part, you will see the word ionized part. The unionized part is the one that the body will make use of, whereas the ionized part, the body will poorly make use of it or may not make use of it at all. Okay, and so there is need for your production to be in terms of weakly acidic form or weakly basic form. Yes. Okay, let's see. Let's discuss what happened to what weak base in full. Weak base can be represented with B from the word base. Okay, when it ionizes or when it is dissolved in water, dissociation or ionization will now take place. It will dissociate to this and what? This. Now, these are the ionized part. Why the one that will remain is called the unionized part? Yes. Now, let's take the ionized part to be A. The fraction of the ionized part, let's call it A. This is fraction of the ionized part, FIP. Then, let's call the one that is unionized. So, fraction of unionized part, FUP. Let's call it X. Remember that total fraction we have is said to be 1. That means fraction of the unionized part will be equal to 1 minus what? A. Fraction of the unionized, that is X, is equal to 1 minus A. Understood? We call this side 1 minus A. That means whatever remains here, what didn't ionize is called the unionized part. Yes, from the topic weak base ionizes partially. Are you getting it? Okay. Now, we now say, okay, the dissociation constant K of the base, Kb, because we are talking about base, we call it Kb, right? Is equals to concentration of the ionized part, product of the concentration of the ionized part, all over the unionized part. Okay, what are the concentrations? So we call this your A, you call this your A. This is 1 minus A. What you have gotten is fraction of the unionized, fraction of ionized, fraction of ionized. But the question is, what will now be the concentration? That means the fraction of the ionized times the total concentration will give you concentration of the ionized. This fraction of the ionized times the total concentration will give you concentration of the what? Ionized. This unionized times the total concentration will give you concentration of the unionized, because what we are using here is concentration. That is why we need to get the concentration of all this. Okay, then this is what? AC times AC all over 1 minus A times C, right? Remember that this is the unionized part. So this unionized part has only the unionized part, and so this A we call the ionized part will be said to be 0. This A will be said to be 0 because only here is only made up of unionized part. Look at where the ionized parts are. So the unionized part is very small, infinitesimal, insignificant. So we say it is 0 because it is majorly dominated by unionized part. Are you getting it? Okay, so when I say A is 0, we now say this times is divided by this. What we now do is this minus this. This is 0. 1 minus 0 is 0. 1 minus 0 is 0, right? So this is A times A square C. That is equals to Kb. Okay, we now say therefore let us make this A, which is the ionized part, subject of formula, because we need it for us to get the concentration of this OH. We now say A is equals to square root of Kb over C. Are you getting it? Now look at this OH. Concentration of OH, which determines the base, or which tells you, or which represents the base, is equals to, what is the concentration? A times C. Therefore, what is your A? You say concentration of OH is equal, what is your A? Square root of Kb over C times what? C. Please be very careful when you come to this step, because this, if you just do this, cancel this, it means you have made a big mistake, and so don't do that, because this is not inside the square root sign. So what you do is that note that C is equal to square root of C squared, and so I'll bring it here. Therefore, concentration of OH is equals to square root of Kb over C times square root of C squared times square root of C squared. That will be giving me to be equals to square root of Kb C squared over what? C. It is at this point, because both of them are inside square root, this can now come inside. So this can cancel this. Therefore, we said that concentration of OH is equals to square root of KBC. Okay? Now recall that in the first part of the video, we realized that concentration of hydrogen times concentration of OH will give you ionization constant of water. So KW. Are you getting it? And so therefore, making concentration of H subject of formula, because when you talk about pH, we say pH is the measure of hydrogen ion concentration. So concentration of hydrogen is what we make subject of formula, is equals to Kw all over OH. Concentration of OH, Kw, or what is the concentration of OH? You say is equal to square root of KBC. Okay? Now what we do here is, since note that negative log H concentration is what we call pH, right? So I will take negative log to both sides of the equation. Look out. Negative log this is equal to negative log bracket Kw over square root of KBC. I've taken it. So this will be giving me pH. That is the pH of a weak base equals to, let me simplify this. I will keep minus. Logarithm log will come in. This will be giving me log Kw. Because of this division, I will put minus log. This one will give me KBC raised to the power of half. Because of this square root, I will close it. Therefore, my pH is equals to, I will now bring in this inside. It will be giving me, okay, as this is here, let's sort out this inside. Minus bracket log Kw minus, this half will come down, 1 over 2 log. Now, this is KBC. KBC. We are just making subject of formula. Now, watch what I will do. I will now say pH is equals to minus bracket log Kw minus, for this one, I will keep this half bracket, take care of this logarithm. I will say log Kb plus log what? C. Therefore, pH is equals to, watch well, expanding. If we are expanding, we'll be having minus log Kw minus log this, right? Minus times this is what? Plus minus times this is plus half log Kb plus half log C. You can see now, we have arrived at this point. Now, it is important for you to know that this is what we call pKw, right? And this one is log Kb. Okay, note that minus log Kb is equal to pKb, right? And look at what you are seeing here, 1 over 2. So I will come and say, do you know that minus bracket minus 1 over 2 log Kb is the same thing as 1 over 2 log Kb. We have 1 over 2 log Kb. So minus this will give you what? This, right? So what we now do here is we now say pH is equals to minus log this is called pKw. Then come to this, I will say minus half, minus, I'll bring out this half, it will remain minus log Kb, minus half bracket minus log Kb plus half log C. Okay, so therefore finally your pH is equals to pH of a weak base is equals to minus log Kb is called pKb, pKw minus half pK what b minus half pKb plus half log what C. You see, so this is the formula you will use to get the pH of a weak base. Remember, when you hear pKw, it means minus log Kw. When you hear pKb, it means minus log Kb. Okay, so this is formula you will use to get pH of a what? Weak base. So you see questions on this weak base on our channel.